Okay, Algebra 2, Unit 3, Lesson 17 is called Completing the Square and Complex Solutions. So our goal is I can find complex solutions to quadratic equations by completing the square. So a couple of things to review. A complex solution is A plus BI, all right, or a complex number is A plus BI. Quadratic equations, AX squared plus BX plus C, that's standard form. You could have X plus some number. We'll just say H squared equal to some other number, call it a constant. If you have this form here, you could complete the square or quadratic formula. If you have this one, you're going to use square roots. Okay, so when I say square roots, I'd square root both sides, get plus or minus radical C equals X plus H, and then you move the H over. Now, H will be a number, obviously, and so will C, but that's how you would do square roots. Quadratic formula, hopefully you remember that. X equals negative B plus or minus the square root of B squared minus 4AC. All of that's over 2A. That's my quadratic formula. This is my square roots. Complete the square. You're going to add B over 2 squared to both sides. So I'll come over here, add B over 2 squared to both sides. All right, that's basically your first step. And then you'll factor the left, add the numbers on the right, and then it turns into a square root problem. All right, so match each equation in standard form to its factored form and its solutions. Okay, so this is a difference of squares. So it's x minus 5 times x plus 5. So then you get this one here. So match those. And then obviously if I set each factor equal to 0, make two equations here, add 5, I get x equals 5 and negative 5. So that'd be these ones right there. So if I go that route. Over here, x squared minus 5 equals 0. Maybe if I move the 5 over this time, instead of factoring it, because this isn't a perfect square, and get x squared equals 5. So I get x equals positive and negative radical 5. So we know this number 2 is going to have these here. And then if I want to do my factors, I would do x minus each factor, x minus the square root of 5. Excuse me. And then x plus the square root of, or x really minus negative 5, which double negative turns into a plus. Okay, so I would get for this one, it would be here and then here, okay? And then that would make the last one this route. Let's do it though. Come up here. X squared plus 25 equals 0. If I wanted to use square roots to find the zeros, and then I can factor it from the zeros. So we got to put our plus or minus when we insert the square root. The square root of 25 is 5, but see, when you have this negative here, you got to remember it's really the square root of 25 times the square root of negative 1, and you got to know the square root of negative 1's I. Okay, so that's these ones, and then we just do x minus 5i, and then x minus negative 5i. So a double negative there is going to turn into a plus. So that's how we get those answers there. All right, so these are set up to use square roots because I have something squared by itself equal to a constant. So I'm just going to use square roots here. See, square root both sides. So your square root gets rid of your square. You need a plus or minus here, but since it's 0, in this case, I'm not going to put the plus or minus because there's no such thing as positive and negative 0. So I have to add 5 to both sides, and I get one solution, x equals 5. Now, if I wanted to check it, plug it back in. So 5 minus 5 squared equals 0. Well, 0 squared, 0 squared, 0. So it works, okay? Let's go here. Square root both sides. Square root of 1 is 1, but I need to insert that plus or minus because when you square root both sides, you have to have two solutions. I got to get x by itself. So this is 1 plus 5, and then it's also negative 1 plus 5. Now I can add those together, and I get 6 and 4. Those are my answers. Now the last one, we end up getting complex solutions because we have the square root of negative 1. Square root of negative 1 we all know is I. I can't add a 5 and an I, so I leave it like that. So it's 5 plus I and 5 minus I. Now you could write it as plus and minus, but I found that when kids write it like this, when they write x equals 5 plus and minus I, they don't realize that this is two complex numbers. They think it's one number, which it's not. It's two numbers. I have a plus bi, a plus bi. Okay, it's like a is 5, b is 1, a is 5, b is negative 1 over here. Okay, so I've just seen too many people when they write it like that, and then I ask you, how many complex solutions are there? And they write 1. That's wrong. Okay, there's two solutions right here. All right. Now, what if it's not in that like binomial squared form? We have to complete the square to get it in that form. So on this one, first thing you're going to want to do is move your constant over to the right. I leave a little space here. And I'm going to just put plus blank, plus blank. And what you're going to add here is b divided by 2 squared. You're going to add that to both sides here. So negative 8 divided by 2 is negative 4, and then you square. So I'll write the whole thing out here. Normally I do this part in my head. I just kind of do negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So I usually skip that step and I just jump right here. So these numbers, you add them together on the right. That's pretty easy. These I factor. So we end up there. Okay, now I skip the step where, some people might want to, make a box. You put the x squared here, put the 16 here. We go x times x, 4 times 4. Add those up, we get the 8. Oh, shoot, it's got to be negative 4. Negative 4, whoops. Negative 4 plus negative 4 is negative 8x. Whoops, missed my x. Okay, so anyways, once I get it to here, it's almost the same as this problem. You square root both sides. Square root, square root. So we get 4 plus and minus the square root of 3. So I have 2 Those are real numbers. They're just irrational when I have that radical there that can't be simplified. So we would call those irrational solutions. All right, on to the next one. Really same idea. Really, it's the same equation. The only difference was C. So same thing, B divided by 2 squared. So it's going to be 16. This is going to be the same thing when you factor it. All right, and I don't need to redo the box. I already did on the last one. Square root both sides. Okay, so here we have square root of a negative. So hopefully you picked that up when we covered that. This is equal to the square root of 3i. Okay, so this is imaginary because I have the I. I still have to get x isolated so that it's solved for x. So it's positive 4 plus or minus square root of 3i. So I would call these two non-real solutions, okay? And they're actually complex, okay? Complex, remember we said is a plus bi. Go back to that last one. I have two real solutions. Okay, they're real numbers. I can type this into my calculator and get a decimal. We just call them irrational because we have that radical that cannot be simplified. All right, so these are, if you look here, these are all the same. The only difference is this number here, okay? So we're going to see what happens here. Move it over. So I'm going to kind of do all three of these simultaneously. Okay, so I'm going to add b divided by 2 squared. So 14 divided by 2 is 7. 7 squared would be 49. So I add 49 to both sides. And since this is the same on the left of all of these, I'm going to do it to all three at the same time. So when I factor this, it's going to be x plus 7 squared. 7 times 7 gives me 49. 7 plus 7 gives me 14. And then I add these. So this is going to be the exact same thing again because the left side's the same. So what you notice here is we're going to square root both sides for all of these, but here we get a positive number square rooted. So these are going to be real solutions here. I'm actually going to have two of them. I have negative 7 plus the square root of 5, and then I also have negative 7 minus the square root of 5. So I have two real solutions, okay? And when I say real, they're also actually irrational because you have that radical that you can't simplify. Same idea here, square root both sides. X plus 7 equals 0. So this I can subtract. 0 minus 7 is negative 7. So I have one real solution. And this is rational because it's not a radical that you can't simplify. So I'll just write here, this is called rational because it's not a radical that can't be simplified. Square root both sides. So this becomes square root of 5 times I minus 7 from both sides. Make sure the I is not under the radical. So those are my solutions here. So since I have A plus BI, this is 2 complex solutions, okay? And complex are always non-real, okay? So when I say real or non-real, real solutions will be on the x-axis. These are your x-intercepts. So, I'd have to type it into my calculator to kind of see like where it is, like and get a decimal. But these will have x-intercepts if you were to graph it on your graphing calculator. This would have the vertex on the x-axis because x squared will give you a parabola equals 0. Obviously, that's the x-axis. The only point that a parabola can hit the x-axis at one spot would be right here at the vertex, okay? And then this would be one, this is my x-axis. Here's one where it crosses twice. Two solutions, and this would be one that would look like this. Here's my parabola, and here's my x-axis. So we have no real solutions. We have no points that hit the x-axis. Here we only have one. Here we have two, okay? So those are really the only scenarios you could have with the parabola. Two solutions, one solution, or no solution. When I say solutions, I mean real solutions. Two real, one real, or no real. Okay, so let's see if we can streamline this to make it easier. So what determines, let me go back. Let me add a slide here. So let's say I wanted to use the quadratic formula. So what determines if you have one solution, one real solution, two real solutions, or no real solutions? Well, it's this radical here. So what happens is if b squared minus 4ac is positive, then we're going to have two real solutions. Why? Because you square root a number and you add it and then subtract it. So you're going to get two different numbers. If it equals 0, we're going to have one real solution. And again, why? Because when I add, if it's 0, when I think about this, when I square root 0, I get 0. So if I add 0 and then subtract 0, it's the same number, okay? And then the last part is when it's less than 0, we have two complex solutions. And that would be complex numbers you should know by now are non-real. So that would make sense. If this is a negative number, you get a negative under your square root, you're going to get an I. So let's just say it's -4. Okay, well, it's going to be plus or minus 2I. So we're going to have, whatever this value was here for B divided by 2A. So we get the I's there. So that's why. All right. So we can streamline this here if you have this info in your brain. So we want to check b squared minus 4ac. See if it's positive, negative, or 0. So this is going to be -8 squared minus 4 times 1 times 13. And let's see what that gives us. So it's going to be 64 times minus 4 times 1 times 13. So I get 12. So what that means is you're going to basically, with your formula, it's going to be plus or minus square root of 12. So that's a real number. So this is going to be 2 real solutions. Over here, it's going to be -8 squared minus 4 times 1 times 16. So that's going to give me 0. So if you add or subtract square root of 0, okay, you're going to get the same number. So this would be 1 real solution. And the last one, negative 8 squared minus 4 times 1 times 19. So I'm going to get negative 12. So if this is negative, we're going to have two complex solutions. So if they're complex, we're going to just say two non-real or complex. But it says how many real and how many non-real. So I'm going to answer my question the way that it said. All right, so the graph. So I kind of already like led into this. So the first one, if I have two real solutions, I should have two x-intercepts. So for this one, you see here, I have my two x-intercepts. Okay, so I'm going to write two x-intercepts. Okay. This one has one real solution, so I should have one x-intercept when I look at my graph, which I do. Okay, so there it is. There's my one x-intercept. And if I have no real solutions, my graph is probably not going to touch the x-axis, which it doesn't. Okay, so this one here is no x-intercepts. Okay, so that makes sense there when you think about it. All right, so lesson synthesis. How do you know when imaginary numbers will show up when solving a quadratic equation? So I would say that happens if b squared minus 4ac is less than 0. All right, there's actually a name for that. It's called the discriminant. Okay, that is b squared minus 4ac. That allows us to tell how many solutions you have. All right, without completely solving, x minus 3 squared minus 4 equals 0. So this one, I don't have to FOIL it out to use the discriminant. I could, but what I could do here to make this one easier, a little shortcut, move the 4 over, so I add 4 to both sides. And then you see, oh, I square root both sides. I'm going to get plus and minus 2. So I've already put my radical in here. So I can see, oh, okay, I got two different solutions. So two real solutions. All right, now the other option would be is to make a box and multiply that out, or just, if you can do it in your head, you're going to get negative 6x plus 9 plus 4 equals 0. Combine these like terms. Oops, I missed my squared there. And then check with the discriminant, see if it's positive, negative, or 0, and use that to determine. But that's a little bit more work from the way that the problem is set up. Okay, so over here, same idea. I'm going to use my shortcut. I'm going to move the 5 over to the right. I'm going to subtract it from both sides, square root both sides, and I see right away, oh, I had to square root a negative. So I'm going to have two non-real solutions, which we already said that we call those complex. All right, this one here, when you square root both sides, we're not going to have plus or minus 0, so there's only going to be one number. I'm going to add 3 to both sides, so I'm going to get one real solution. Is it possible for a quadratic to have only one non-real solution? On this one, I would say no, because it will be plus or minus the square root of b squared minus 4ac. So whatever negative I get underneath here, I'm going to add it and subtract it. So you're going to get two different numbers, okay? So we will get two different complex numbers. Okay. All right, so our goal, I can find complex solutions to quadratic equations by completing the square. We didn't really find, well, we did a little bit. We found some solutions. We also found how many solutions we have and the type of solutions. All right, so write a quadratic equation with solutions that are not real numbers. Solve your equation. Okay, so let's see here. We need, remember, b squared minus 4ac. We need this to be negative. So how about this? Let's think here. If this value is very big, if this one's like a big negative number and this is a small number, we're going to have a small number minus a big negative number, and that'll give me negative. So why don't we make b a very small number? Let's make b equal to 1. And let's make a and c positive numbers because it's already a negative 4 here. So let's make a like 3 and c 4. So this is going to be 1 squared minus 4 times 3 times 4. You see what happens here? This number is a big negative number, and this is a small positive number. So if I do this number minus that, it's probably going to be negative. So I'm going to get 1 minus, what is that, 48, I think. So 1 minus 48. Cool, it works. I get a negative there. So my equation is a is 3, so it's 3x squared plus bx plus c equals 0. So there we go. There's my equation. All right, I hope you enjoyed this video, and thanks for watching.